And this time, please let me introduce a Korean compounder, Dasco. Please, a big pleasure to her.
Hello, everyone. Thank you for having your time to join us today. Let me check if we have our presentation. Okay, I'm Min Kim from Desco, and I'm going to introduce about our company and our polycarbonate grade, the recently developed grade. And we believe in a world that is recently really shifting toward electronification and sustainability. And we think in this world, the material you choose is really more, have never been more critical than before. So I hope this session will helpful to you. And as Mr. Hong introduced us, we are super good at inventing and R&D to develop flame retardant grades, especially for polycarbonate grade. So if you have any question about it, feel free to contact us. So here is who is Tesco. Tesco is a global engineering plastic solution company. We established it in 1999, but we looked from 1982, and our annual sales are USD $100 million. And our product capacity is over 30,000 metric tons per year. And we have global subsidiaries in USA, China, India, and Poland. And we have over 350 grade, including polycarbonate, and nylon 6 and nylon double 6, etc. And we also have over 70 OEM material specs from Hyundai, Kia, and GM, and also other companies. Here are Desco's networks. We have 2 plants and 4 subsidiaries in the world. It means our customer can get our grade easily and locally and believably. And here is our partners from Tier 1 and OEM companies. We are a trusted partner to our top OEM companies like Hyundai or GM or Kia and also Tesla. And Tier 1 leaders like Mobis, Allen Klinger, and KSR. This trust stems from execution and quality and versatile portfolio that helps bring their ambitious design to life. Here are Desco's product line. Our product portfolio spans high performance polyamides and our specialty grade Desco, which is polycarbonate. We run over 350 grades for our customers. Also here are the certifications we have. We have, as I said before, we have 40 MS spec from Hyundai Kia company and also 30 spec from GM. Also, we also have international certifications related to safety and related to water system. Also, we have eco-friendly related certifications like GRS. Also, we have our grades applied to manufacturing drawings like for Ford, Volkswagen, and Stellantis. So here is the examples on where our materials are used, and from the front end module and cylinder head cover to like rear end oil fill cap and even door checker. We're a leading company, leading material company for OEM companies. And as the industry pivot to EVs, our role grows. We provide advanced EV capacitor and EV fuse box housing and EV cartridge batteries, etc. With these items are really related to EV electric vehicles, and this is the most popular market nowadays. And beyond the automotive industry, our materials excels in industrial and appliance applications, valued for durability and chemical resistance. For example, pump housing and high performance carrier cable and also connectors. So, what's new from DESCO for this K 2025? We brought high performance polycarbonate grade that de-risk EV and battery and water programs. I really have to introduce our recent grade to you guys. Here are our polycarbonate grade. This is a quick overview of our polycarbonate grade. On-field grade are target high-speed mold release and impact resistance and flame retardancy. Also reinforced grade, combined glass and mineral fillers for rigidity and heat stability and specialized function like thermal conductivity. And today's topic of our DSC TFR grade, which is flame thermal runaway prevention grade. And let's take a look closer each grade. Here are some applications that use our polycarbonate grade. First one is connector and door carrier plate used by our 7500R grade. And second is water and cooling systems applications. And our materials are 7500 G6 and G8, which is reinforced grade. And third, they are electronic housing applications. And our grade is DSC 7500 FRG6 grade. We also have MS specification and GM specification. And fourth, it's our highlight of today's presentation is this grade is made for battery and thermal protection application. The grade name is DS6 7500 TFR grade. I'm gonna talk more about this fourth grade, and we're gonna show you the test demonstration video as well. Yeah, this is first our on-field grade, DSC 7500R, and it's the intelligent and modern replacements for materials like POM, especially in automotive interiors. Because the reason why our customer choose 7500R is its inherent chemistry allows designers to meet strict order and VOC regulation by completely eliminating the issue of formaldehyde emissions that you see with POM. It is safer and cleaner solution. And next, it's another specific case, DSC 7500R, used by our client H Corporation for HKMC EV connectors and fully certified to MS specifications. It was chosen for its clear advantages: high impact strength, dimension stability, short cycle time, beam moldability, and high resilience. And this is for the applications involving water and coolant. We offer our glass fiber reinforced grade, DSC 7500 G6, which is glass fiber 30%. This material ensures long-term reliability in water pumps, thanks to its excellent hydrosis resistance and dimensional stability. It is also certified by leading international standards for drinking water applications like KTW and WRAS and ACS. Yeah, and now it's flame retardant grade. This is our draft reinforced grade. The grade name is DSC 7500 FRG6, which have glass fiber 30%. This is the spec-backed baseline for robust high voltage housings and enclosures holding the critical MS specifications from Hyundai Kia. It's already in production for EV fuse box housing and has been verified and adopted into the bill of materials for next generation inverter busbars and EV capacitors. It provides the certified reserve performance needed to ensure electronic safety, and we are actively working with our OEMs companies on replacement pathway for materials like PPS and MPPO. And here's a highlight of today's presentation. The name of it is DSD 7500 TFR grade, our thermal runaway prevention grade. It is not just another reserve plastic material. It is an engineered thermal runaway defense system. We combined glass and mineral fillers with advanced flame retardants to build a stable char layer that insulates and blocks flame propagation and protect adjust cells. Core effects of this grade is one line: high flame retardancy, electronic insulation, dimension stability, wear resistance, and chemical resistance. What does it take to qualify as a thermal runaway grade? There are three things. DSD 7500 TFR delivers on all three. First, torch and grid test should be over 12 cycles, and CTI should be over 600 voltage. And last, UL 94 reserve flame rating for enclosure safety. The material is already applied to EV battery motor drawings and developed jointly with Hyundai Mobility Automotive Company and supported by MS specification. Okay, before I show you the demonstration video, let me explain what is thermal runaway. Thermal runaway is a violent, catastrophic chain reaction inside a battery cell. A trigger like the internal short or physical damage causes the cell's internal temperature to increase uncontrollably. This leads to the rapid release of stored energy, with temperature start skyrocketing to past 700 degrees Celsius, venting toxic and flammable gas, and leading to pack-wide fire and explosion. Containing this event, even for crucial minutes, it is the difference between a meaningful failure and a disaster. And this is precisely where our material make a clear difference. Over here. When it first starts, it starts with a one cell inside of the, for example, EV battery. And if the product like EV housing used by our material will block to stage 2 and will stop the fire propagation to other cells. So the another big question is how we test and prove this capability to withstand such an extreme event. The answer is torch and grid test, one of the most demanding thermal tests in industry, and a standard required by global leaders like HKMC and UL. Here's how it works. We take 2 millimeter thick sample of our material from the 6 millimeter from the torch away, and we blast it with torch flame heated to incredibly 1,200 degrees Celsius. The test runs a 20-second cycle. For the first 15 seconds, they're gonna be only torch, but the final 5 seconds, we add abrasion aluminum grits into flame to simulate the high energy particle sprayed from exploding cells. The target is simple but critical. To ensure absolute wear size stability for safe inclusion design. And the pass-fail conditions are strict. Any hole, any burn through, or any ignition on the wear side. So let me show you the demonstration video of it. Mhm. Okay, now I'm going to show you a video of the torch and grid test featuring our 7500 TFR grid. To give you a clear comparison, the video will show two materials side by side. On the left is our TFR grid, will be TFR grid, and on the right side is a standard flame retardant material, a polyamide 6 with 30% glass fiber rated to B0. And both specimens are, as I said before, 2 millimeter thick and 1,200 degrees Celsius. Flame gonna be 6 millimeter back between the specimens and the torch. And let's watch and how it will work. Oh, here is the demonstration video. I'm gonna skip the introduction about our grade. Mhm. Just to make sure, this is our TFR grade, and this is the nylon 6 flame retardant grade. And here is our specimen. It's a 2 millimeter thick, and the distance from the torch and our specimen is 60 millimeter. And for 15 seconds, there gonna be only flame over here, and for 5 seconds, there gonna be flame and grit. That's a one cycle, and let's see how long they endure this test. This is one cycle. After 15 seconds, there is a kind of aluminum grit over here right now. And now it's cycle 2. And repeat for 15 seconds and 5 seconds air section. And as you can see, the nylon single flame retardant grade had a hole already during the cycle 2. So we stopped it. But this is polycatone grade, TFR grade. And now it's cycle 3. Let me just skip some scene to how long it endured this test. So it's cycle 5, cycle 6, cycle 8, 9, 11, 13, 15, 17. It's a kind of char layer of polycatone. 19 and 20. Even cycle 20, there's no any hole or no any flame in the backside. And let me show you the backside of this specimen. Here is the backside of it. Yes, flame is over here. And here is the backside of the specimen. This is during the cycle 1. No hole at all. Just let me show you the cycle 2 to show the hole in the here. Yeah, now it has a hole over here, flame in the backside. It means this grade is failed. And this is polycatone TFR grade. Let me skip to cycle 4, 6, 8, 10, 13. Still there are flame over here in grid, but there are no flame or core at all. And yeah, until 20 cycle, there is no hole at all. Let me show you the. Here is the result of the test. Can you switch to? This is the still image from our torch and grid evaluation. The specimen on the left is the front. You can see the char layer over there, and the right one is the rear side. Remain intact, no hole, no burn through, and no flame marks. even after 24 cycles. And we brought actual test statements over here. So after the session, if you want to see the result of this test, you can see here easily, you can check it. And if you like to receive deeper technical data, for example, test setup or cycle logs, feel free to reach out to us or our website. We're gonna share our data, back data share. And this is about the CTI this test. This is the beyond the flame resistance. Electronic safety is paramount in high voltage system. So that's why we also need the comparative tracking index, which is CTI. This test following the IEC 60112 standard measures a material ability to resist the formation of conductive tracks when it contaminated and under high voltage. And as you can see from the table, both our standard flame retardant grade and our thermal runaway grade achieve highest possible rating, PLC 6 grade over here. And also the voltage is over 300 voltage. And so our material have excellent flame resistance and superior electronic insulation. But a critical question remains, what happened to the insulation after an extreme heat event? To answer that, we performed this oven aging test. We expose our material to 600 degrees Celsius for 3 minutes, and that measure its electronic resistance. And the results speak for themselves. Basically, the material remains intact with no hole or damage, and electrically, the multimeter give a reading of OF, which means overflow. As note explained, this means the electronic resistance is particularly infinite for both grades, the FRG6 grade and TFR grade. Yeah, we're already co-developing additional battery module components with our partners using TFR grade. And we see a future of GSC TFR grade far beyond the car actually, industrial energy storage or fire rescue equipment and aerospace electronics. Anywhere thermal runaway contaminant matters. With this TFR grade, you get the defense plus the intrinsic benefit of polycatone, like a lower CO2 footprint, low moisture absorption, and excellent chemical resistance. So if you're looking for the right material for your drawing or a partner for dedicated development, please visit our website, edesco.co.kr, or email me, mjkim and edesco.co.kr. If you'd like to see and handle what we discussed, we brought several polycatone specimens, so including TFR grades. So please come and say hello after this session. Thank you for your time.
Thank you for great presentation, Ms. Min-Jung Kim. Thank you again. And before we go to the acrostic, just we have some questions. So maybe it would be better to have a question and answer. So number one is that what is the maximum pressure if we use for pipe?
I don't know the exact application for pipe application. It depends on the grade, and normally we recommend the M710 and M730R for pipe application. So if you let us know the thickness and the outside diameter of the pipe, then we can match the pressure for pipe application. In case of MLS value of our 30% glass filled material, the value is around 11.2 megapascal at 23 degrees C for 50 years. And another base material is M630F. It is the 14.2 megapascal for the same age and the same temperature.
Thank you, answer, Mr. Odipan. And the second question is that, can you tell us about your capacity to scale up this material production? So please let me answer to you. Currently, our production capacity is 50,000 metric ton. And after that, we are available to build up by 50,000 metric ton capacity every unit. And third question is that, do you have any approval with the American Petroleum Institute API?
I think you know that, right?
Okay, not 100%, but please let me tell you, we don't have it. So API is kind of a standard by steel requirement in America. But so far, we do a specific test name and institute. We do a trial and error and get trustful information. So for example, like SWRI, Southwest Institute of Technology located in San Antonio by US government. We do NACE TM 0185 test. So we can give you some another trustful data for you if you are interested in. So please feel free to ask us, or we can discuss together. And another question is that, do we need a special extruder or injection screw?
Well, in case of injection molding, most of the injection machine can be used, and not only we are recommending is that the single foot fly screw is better, and we don't want to increase the share when you do the injection molding. So single foot fly screw is better, and it's the same situation in extrusion application.
Thank you. And next question is that, can you do the flame retardant and CTI test in-house?
Not really. We normally do the test at UL, and we have tested a lot of UL tests. And recently, we've got some tests for the recent test is the STT, the surface tracking test. It is the new version of the CTI, and we tested some of our grades, and we've got reached about not over 975 volts. So I will share it with some of the data after the session.
Thank you. And last question is that, why didn't you let the test continue after 20 cycles? I think that is for the decimal question and answer.
As I know that they set the specification until the 20 cycles, but if they have tested at over 20 cycles, then it is okay. But not sure what is the last test cycle, but if you over 20 cycles, as I know.
If we test later about it, we're gonna try over the 20 cycle later, and we're gonna share the time. These are of it.
Thank you very much.